For this problem, we are going to use a Riemann sum using the lower right corners and the upper left corners of the rectangles in the Riemann sum. And to do the Riemann sum, we are going to plug in values into our definition number 5. So from the problem, we know that rectangle R is bounded by 0 and 4 for x, and -1 and 2 for y. From knowing m equals 2 and n equals 3, we can find the lengths and the heights of the rectangles in the Riemann sum. So for our lengths, we are going to use x and take the end point subtracted by the start point divided by its m, which is 2, to find 4 minus 0 over 2 equals 2. This is our length, or our delta x, whatever you want to call it. For our y, we're going to do the same thing. The end point subtracted by the start point divided by its n to find 1. And this is the height, or delta y. We can also find the area of these rectangles, knowing that the length and the height is 2 and 1 respectively. Delta A is equal to 2 times 1, which is just 2. And then we can also find that our f of xy is equal to 1 minus xy squared. Now we need to find the sample points of the lower right corners for part A. So for our first rectangle, we're going to start from the minimum x and y values, which is 0 and -1. First rectangle starts from 0, -1, has a length of 2, and a height of 1. But the lower right corner will be here at 2, -1. Then we can continue adding our length until we are outside of the x bounds. So we will stop at 4, -1. And then we can add our heights until we're out of the y bounds. If we add another y to find points with y equals 2, the lower point will be in the bounds, but the rest of the rectangle will be outside of the y bounds. So our maximum coordinate point will be at y equals 1. So now we can plug in these values into definition 5 to solve A. The double integral can be approximated by the summation from I equals 1 to 2 and j equals 1 to 3 of f x sub I y sub j times 2, which is our delta A. And from this, you will get f of 2, -1 plus f 4, -1 plus f 2, 0 plus f 4, 0 plus f 2, 1 plus f 4, 1 times 2. Plugging these points into our function, we find that this will equal -1 plus -3 plus 1 plus 1 plus -1 plus -3 times 2, which is -6 times 2, which is -12. So that is our answer for part A. For part B, we need to use the upper left corners. So for the first rectangle, the upper left corner will be at 0, 0. Adding 2 to the x value, our next point will be at 2, 0. And then the next rectangle will be outside of the bounds. So then we can add our y values. So we will have 0, 1, 2, 1, and then 0, 2, and 2, 2. Now we can plug that into our definition 5. Plugging in these points to definition 5 will give us the sum of f0, 0 plus f2, 0 plus f0, 1 plus f2, 1 plus f0, 2 plus f2, 2, all multiplied by 2. And this is equal to 1 plus 1 plus 1 plus negative 1 plus 1 plus negative 7, all multiplied by 2, which gives us negative 4 times 2, which is equal to negative 8. And that is our answer for part B.